So now it's time to talk about creational design patterns. Up until now, we've talked about what design patterns are, where they came from, and we've talked about how objects work in JavaScript. Now let's actually take a look at some design patterns specifically and how we implement them in JavaScript. Now, creational design patterns are used to create new objects. So if I want a new object of some type, I'm going to pick a design pattern that's used to create those new objects. I'm going to adapt how I create those objects to the specific situation involved at the time. So there's several design patterns involved, and we're going to talk about how and why we would use each one of them individually. Now we're going to start off with the constructor pattern, which, depending on where you look, isn't a design pattern from the original Gang of Four, but it's different enough in JavaScript that we're going to spend a little bit of time talking about constructing new objects. And so the constructor pattern for us for right now is used to create new objects with their own object scope. So if you're coming from .NET or Java or some other object-oriented language, this would be creating a new instance of a class. Now, JavaScript doesn't have classes, at least not until ES6, and we'll talk about that here in just a little bit. But JavaScript does enable you to create new objects out of existing objects, and so that's going to use the constructor pattern. So when I do the constructor pattern, we're going to use the new keyword. And the new keyword does a few things when you use it, when you stick it in front of a function. So if you take a function, any function, and you drop the new keyword in front of it, it creates a constructor function out of that function. And when that's executed, it's going to do all four things. It's going to create a brand new object. So when I put new in front of a function, it's going to create a new object, which is kind of what we want to do. So that's the right thing. It's also going to link that object to an object prototype. If you're surfing the internet and you start looking at prototypes, it says that it inherits from or it does things like that. That's not really the case. It links to that object prototype, and we'll talk specifically about that here in just a little bit. So we'll come back to that, but it links the object to that object's prototype. It binds this to the new object scope. So we'll talk about the this keyword and how that works, but it creates a new this and binds it to the object scope. And the last thing is it actually returns this. So if we look at some code, this is a constructor function in the constructor pattern. Now, like I said, any function can become a constructor function, but for what we're talking about, this is how we would lay out a constructor function. Now, what the constructor pattern allows us to do is to create a function, and I can pass in some parameters to that function. And the name of the function is going to be the name of our object. So in this case, I'm just calling it object name. I'm creating an object called object name, and I'm passing in two parameters to my constructor. Because I'm going to use the new keyword, I have this now available to me, and it's bound to this object scope. So this.param1 and this.param2 are being assigned whatever I'm passing in. And I also have the option to do methods on this. So my object now has a toString method that's going to return param1 and param2. This is the basic outline of how a constructor pattern works. Now remember, the fourth thing that the new keyword does is it would implicitly insert a return this at the end of this function. So the very last line of this function would be return this. And I don't have to do that explicitly because the new keyword is going to do that for me. All right, so let's try this out in our Node environment and see how this plays out in practice. So for us, we're going to do this inside the idea of a task application. So we're building an application that's basically just a task manager. So I'm going to create a new file called task.js. And what I'm going to do is create a task object. So we're going to start by creating our task constructor. And if you remember, we create a task constructor just by creating a function. So in this case, I'm going to call it task, and we're going to create a function that we're going to put everything in. Now in this case, I'm going to pass in name. So whenever I create a new copy of our task object, I'm going to pass in the name, and I'm going to create a task with that name in it. So the first thing we'll do is this.name equals name. The other item on task that we want to keep track of, so if you think about a task application, whether or not it's completed. So in this case, the default is going to be false. All right, now I have a task object, and it has this dot name and this dot completed. Those are the only two things. Now what I want to do is I'm going to add a function to this. So this dot completed equals a function, and this function is going to change the value of completed. So let's just say that. So this dot completed equals true. Now let's create one more. Let's do a save as well. So this dot save. So once I make changes to a function, I want to save it to the database or something like that. And in this case, we'll just write out saving. We'll just say saving task and then give us the name. All right, so now I have a constructor that has two properties, name and completed, and then two functions. Completed, or let's actually not call this completed. Let's call this complete. And we'll put a CL on this too so you see what's happening. We'll just say completing task and then task.name. All right, so now I have a constructor ready to go. Now to use that to create a new instance of this object, I am going to say var task1 equals new task, and we'll pass in our task name. We'll just say that's what we're doing. Now I can create a couple different instances of this, or to use the correct terminology, really in this case, I'm just creating several copies of this object because we don't have classes in what we're doing here. So I'm creating an object and then I'm just making copies of that object. So there we go. And then we'll do constructors. We're going to do modules. We're going to do singletons, and we'll do prototypes. All right. So I have 4 copies of this object, and they all have their own individual object scopes. So I can do task1.complete, execute that, and then we can save all of them. And you can see when I run this that they all have a separate this. So when I execute task4.save, up here the save on line 11, you can see I've got this.name. And so the this refers to the object scope of whatever object is calling the save function. So in this case, task4.save refers to the object scope of task4. So the this refers to task4. So what you'll see is this.name being, in this case, create a demo for prototypes. Real quick, before we show this, let's make that this. All right, now let's run this. There you go. Now what you see is there's completing task, save, save, save for each of the different things. All right, so that's the basics of the constructor. Let's talk about one other thing before we make this fleshed out a little bit more. All right, now one issue we have with what we're doing so far is that the function toString is reinitialized, is recreated for every task object that we create a copy of. So if I have 4 task objects like we did in our demo, this toString function was recreated all 4 times. And that's not really efficient behavior. That's not really how we want things to work. And so what we've been given is this concept of prototypes. And what a prototype is basically just an encapsulation of properties that an object links to. So I can have properties and methods that are on an object's prototype, and for every copy of that object that I have, it all links back to the same prototype. It's much more efficient to have one copy of all of those object methods out there sitting inside the object prototype. So think about it like this. So we have our task object, and that task object has a task prototype. So in this case, the task prototype, we would put that complete and the save method on the prototype instead of inside the task object. So when I create 2 copies of task, they both point back to that same task.prototype. They don't copy, they don't inherit from, or they don't pull those methods into themselves. They are truly linked back to the prototype. So let's take a look at that and see how we would change things to work that way. So let's take a minute and adapt our task constructor, our task object, into this prototype means of a constructor. So basically what that means is we want to take the complete and the save out of the constructor and just attach it to the task prototype. And the way we're going to do that is by just using prototype. So its structure is class name dot prototype dot method name, and then you pass in whatever arguments to the function. So in our case, we didn't have any arguments, but that's the way that works. So here we're going to go task. Our method name is going to be complete, and then the function is just going to be this function right here. So we'll paste that down, get rid of our arguments because we don't need that. And now we have complete on task's prototype. So now every time I create a new copy of task, I'm not creating a copy of the complete function. That complete function exists in one place on the task prototype, and all of our task copies have access to that complete function, but they don't have their own copy of it. So let's do the same thing for save. So it's task.prototype.save, copy our function, get rid of our arguments. There you go. Now we have just the this.name and this.complete that get copied from one object to the next, and the save and complete methods do not. So let's run this again, and what you'll see is that nothing has changed. There you go. Everything still works exactly the same way, but now we're working in a way that is much more efficient. Now let's take a look at this in the Node environment and actually separate this out a little bit so you can see how to insert this task object into a Node application. Now the first thing we're going to do is create our new file called main.js. And this will be where our actual application would be. So we'd stick everything over in main. And our task.js is simply going to be our task object. So I'm going to copy all of that, or not copy it, but delete it, and move that over into main.js. So in main.js, we're going to actually create 4 tasks, and then task 1 complete, all of this stuff over here. And our task.js is just going to be our task object declaration, kind of the constructor declaration and how that works. Now in Node, it uses the CommonJS framework. So we're going to do module.exports, and we're actually going to export task. That's all we're going to do. And what that gives us is a reference to this task constructor. Now we're not exporting a newed up version of it. We're just exporting task. Now over in main.js, we are going to do a var task equals require, and we'll do ./task. Now that gives us task. And now everything just works exactly the same way. So I'm newing up a task 1, and everything's fine. So this is how we break that apart. On our task.js, we create our constructor, all the prototype items, and then do a module.exports equals task. And then in main.js, we're going to do exactly what we were doing before. We do a require task, and then new up our tasks as we go right there. And I can call all the methods and everything just like that. If we run this, now instead of running task.js, we'll run main.js, and everything still works. So this is how you start to break this out and use this in your Node environment. You create your objects in one file, and then you can use those objects by newing them up over in the rest of your application. Now, we'd be a little remiss talking about classes and constructors and all of that stuff in JavaScript if we didn't talk about ECMAScript 2015. Because in ECMAScript 2015, we now have classes that we can use. So let me show you how to take what we just did with our task object and turn it into a class in ECMAScript 2015. Now we're going to do this on the Node side, and I'll show you how to lay that out because Node 5 allows me to use classes, but only in strict mode. So you've got to do the use strict up at the top of your JavaScript file. And what that means is that now this operating in strict mode in Node 5 gives me access to some of the ECMAScript 2015 features. And so what I can do now is use the class operator on my object. And so if I take this task, I'm just going to take task and drop it in here into a new class.js. And what I am now allowed to do is I am allowed to use the class keyword, and I can say class task equals. And this is going to start to look a lot more familiar to everybody if you're coming from an object-oriented .NET or Java background, because now I'm going to create my constructor. I just have my class, and now I have a constructor. And that function that I had before in my task.js, my task was actually a function. Now this function becomes my constructor. And so now I have a constructor with this.name and this.completed. Now that's only half of it. I can get rid of my prototypes now and take this function and actually just create my functions. So I've got complete and I've got save. And wrap that all inside of my class. So now ECMAScript 2015 allows me to just create a class with a constructor, and then methods and variables and all of that stuff can be on that task. If I take my main, I'll take these lines of code and drop them in class just so we can execute this and so you can see what it looks like. We'll run this real quick. You see we got an error, and that's because we don't do that anymore. Now we just have that. All right, now let me run it. And you see completing task, saving task, all that stuff still works. It's just a very different way to do pretty much exactly the same thing. And it might be a little more comfortable for some of you coming from a .NET or a Java background. Now you can do this right now using a transpiler if you're not doing Node. You can use Babel to transpile this down to ECMAScript 5. And what that's going to end up looking like, if I used Babel to transpile this JavaScript file, it's going to come out looking something like this. It'll look a little bit differently because they have reusable code and they call some functions. But ultimately, when you transpile a class that looks like this, it's going to end up coming back over and putting everything on the prototype the same way we do here. All right, so that's ECMAScript 2015 and classes, and you have access to that either through a transpiler like Babel, or if you're using Node 5 or higher and you are running in strict mode. Now let's take a look at this in the Angular environment and see how we would use this same task object and the constructor pattern over on the Angular side. Now I have a very simple Plunker task management application built already out on Plunker, and if you go to the URL, you'll be able to see the same Plunk that I'm using on your browser. Now I have a very simple task management application that basically just takes a list of tasks and dumps them out to the screen. It only has name and whether or not it's completed. If you go to script.js, you'll see I just have tasks and an array of tasks. And a lot of times, unfortunately, this is kind of the way we build Angular applications. You pull data from an API somewhere, it gives you back an array of items, and we just iterate over those items and dump them out to the screen. And that leads to a couple of problems with everything being in your controller. First of all, controller bloat means my controllers are huge. I've got some services, but really we're not doing much with those other than just pulling things out of an API. And it's not laid out in a very clean and maintainable way. And so let's inject some objects into our Angular application so we can start to pull things apart a little bit and not have everything sitting in our controller. So the first thing we're going to do is we're going to take our task object and we're going to put it into Angular. So we'll do a new file and we're going to call it task.js. Same thing we did before. And like all Angular applications, we start out with an IIFE so that we're not injecting anything into the global scope. And we're going to look for our task manager application. Now in this, we're going to use the same task thing that we used before. So we're going to create a function, and that function is going to take the name. And this task is going to look exactly the same way it looked over on the Node side. Create a task function, it's got a name, it's got completed, and then we've got our task.prototype has complete and save. The same thing. Now, in order to put that into our Angular application, we need to add that to a app factory. So we're going to do app.factory task, what we're naming our object. So in this case, we're naming it task, and then a function, and that's how that works. Now, in this case, we're going to wrap our task and our task prototype calls inside this function. And then at the end of this function, we're going to return task. So the same thing we did with module.exports over on the Node side, now we're just doing return task on the Angular side. So basically what this does is this loads into Angular a task object. So your task constructor and your task prototype and all of that is now loaded into Angular, and Angular says, hey, I now have a task that is a constructor function and some prototypes. And so now I can use that anywhere that I need to just by letting Angular know I need it. So if I come back over to script.js, I can now tell Angular, hey, this task controller needs a task. And now I can new up tasks this way. Now, I'm going to do something a little bit differently. Notice how right here on line 7, I have an object. I've got an array of objects instead of just names. So what we're going to change our task a little bit to match this. I'm going to say new task and pass in the object instead of just the name. So we'll go back and we'll change our task just a little bit because I want to be able to pass in completed as well. Instead of breaking it out into a bunch of different parameters, we're just going to pass in the object. So let's go back over to task and change this up. Here we're going to just say data, and we'll do data.name and data.completed. All right, now back to our script.js. Now I'm using task objects. And my task actually has a complete function. So when I was checking this checkbox, if we go to index.html, I've got an ng-click. I'm using my controller.complete method to complete this task. And I don't need to do that anymore because my task itself, if you look back in task.js, my task has a completed method on itself. So now on my index.html, instead of saying controller.complete $index, I can actually just go task.complete. And now let's run that and see what happens. Now I'm pulling everything back from inside my task instead of in my controller. So my script.js, I can actually get rid of this .complete completely and just have my tasks deal with all that functionality. If I refresh, notice it stays the same. And just so we know, we'll set that one to false, refresh, and if we look at our console, when I click check, we're getting completing task 2. If you remember, that's my save function on my prototype. So now what I've done is instead of having all that functionality in my controller, I've moved all of the save and manipulate functionality out of the controller into my task object. And my task controller actually shrunk by about 5 lines of code when I did that. All right, so that's the constructor pattern for Angular and Node. Let's move on and look at a couple others. Now, the next pattern we're going to talk about is the module pattern. And really, the module pattern is used as a simple way just to encapsulate a group of like methods that I'm going to use in my application. So think about it like a toolbox. It's just a simple way to take a bunch of methods that are similar, and I'm going to create a toolbox of functions for me to use. A lot of times what you'll see with the module pattern is things like a service for my database calls or a service for my HTTP calls. Every time I want to do something with the database, I'm going to call this database module, and I'm going to let that deal with all of my database calls. Now, a module pattern at its core is basically just an object literal. In this case, I'm creating a module as a variable that's just an object with a couple of methods on it, method and next method, but they're key values. So in order to execute a method, I'm going to do module.nextMethod, and that's going to execute that function. Just a collection of keys and functions. Now, once we wrap it in a function, we can start doing all kinds of fun things like create private variables. In this case, private var is not on the object literal that's returned in the function call, so therefore nothing can get to it. It's a private variable that's sitting inside this module. Now, the big difference between the module pattern and the constructor pattern that we were talking about before is generally when I'm doing a module pattern, I'm only going to have one of something. So I've got a service, that does all my database work. I only need one of those. And really all it is a collection of functions. Unlike the task that we were talking about before, on the Angular side, we're creating a bunch of them and newing things up. And that's great for constructors, but on the module side, we don't new anything up. We just create a new instance of the module, just var module equals, and execute this function, and that's what we've got. So let's take a minute and let's look at how I do this in theory, and then we'll jump over to practice. All right, now let's take a look and see how we would lay this module pattern out in practice. All right, so if you remember, we have a task object, and this task has a name on it, it's complete, and we've got a couple of prototype methods as well on top of this task. And then we have main.js that just creates 4 copies of this object, and then we save and complete a couple of times. What I want to do now is I want to implement a database service that is a module that'll deal with all of our database stuff for us. Now, to keep this simple, I'm not going to actually go through the motions of doing all the database work because that's really outside the scope of what we're talking about here, but I am going to put in the functions and methods so that you can see how that all would work. Now, what we're going to do is we're going to create a new file called our task repository. Well, let's rename that to be .js. All right, now this task repository is going to be responsible for doing all of our database calls. And so if you remember from the slides, basically we just create a function. So var repo equals a function. And then I'm going to return an object. And this object is just going to be a series of methods that are going to be relative to database stuff. So database gets, database saves, those types of things. And then I'll use these methods over in our main and our task in order to work. So let's create a couple of methods. We'll do a get, and get is going to be a function that's going to take an ID. And we'll just write out to the console in this case, getting task ID, and that'll simulate us getting something from the database. And then we'll actually return just a JSON object with a name. And we'll just call it new task from database. So basically what this simulates is I've gone out to the database and I've pulled back a task and I return that task up to the calling function. All right, so there's my API essentially for my repository. So now I'm just going to export module.exports equals repo. And I can go ahead and execute this right here. So module.exports is actually going to be this return section right here. All right, so let's try that and see if that works. So if I go back over to main where I have var task equals require task, now I can have var repo equals require our task repository. And now I can do task 1, instead of saying task 1 is this, let's just get rid of that. And now I can say repo.get and pass in an ID. And then wrap that in the new task. So now I'm creating a new task, and I'm using my task repository to go out to the database and get that task back. Now, one thing we want to change is notice I was sending a JSON object back with name. In my task object, I'm actually passing in name. So let's just pass in a JSON object with some data in it. And you'll actually see this a lot. Instead of my constructor taking 12 parameters with all the different things, I'm just going to take a JSON object and have that object be my list. So there we go, data.name. All right, so let's try this out and see if that works. What I should see is getting task 1, and then when I do task1.complete, it should say completing task, and then the name of the task would be this one I pulled from the database, new task from DB. So let's try that out. There you go. Getting task 1, completing task, new task from database. So I have a method here in my repository that does my gets. Now that's only one. Let's add another one that does saves. So comma, save, and that's going to take a task. And in this case, we're just going to do a console.log saving task.name to the database. All right, so now whenever I call save on my repository, it's going to save it to the database. Now, instead of doing this from main, let's do this one from task. So I'm going to do the same thing. Repo equals require task repository. Now here, when I'm doing task prototype.save, console.log, instead of writing that, or actually let's leave that there, and now we're going to do repo.save, and I'm going to pass in this. Now in this case, this is the task. So I'm passing in this.name and this.completed into my repository. So now when it says saving task.name, we should see that. Now, if we go back to our main call stack, task2.save, 3.save, and 4.save, you should see demo for modules, demos for singletons, demos for prototypes, all being saved to the database. So let's run that. There you go. To the database, to the database. Now everything's undefined. And the reason for that is because when we do our new task here, we didn't change this to be an object. So let's do that. All right, now that I've changed that, there you go. Now when I run it, you can see saving create a demo for modules to the database, saving create a demo for singletons to the database. This is a module. This is how this works. So basically, I've taken all my database code and I've encapsulated it in this repository object and gone from there. Now, the reason why we want to do this is when this function is executed, I can actually create a variable and instantiate my database connection and do all my database work here. And because of the way JavaScript closures work, every method that gets called, so my get method and my save method, has access to that database stuff up above. Nothing else has access to it. None of my calling functions can get to it. My database is secured up in this module, but all of my methods, my get method and my save method, can have access back up to that database. Now, one slightly alternate method, and a method I actually prefer for this, is called the revealing module pattern. And it basically means instead of doing this, I'm going to get rid of that, and I'm going to create my function up here. And I'm going to define my methods up above, and then down here in my return, I have my list of my methods. And this way, I can just go to my return statement. Anywhere I go into a module, I can go to the return statement and I can see what methods are available on this module. So it's just basically a little documentation for my API that says, look, this module has a get method and a save method. And if I want more details, I can go up and look at them up above. So that's the module pattern in practice in our Node environment. Now let's take a look at this on the Angular side and build that same repository using the module pattern in our Angular application. So far we've got a task manager application that has a task. And basically this task has complete and save. It's got two functions on it. And it's doing this save. And basically all we're doing is console.log saving task. But we don't want to mix our database code. Actually, on the Angular side, our API code, so this would be calling back to an API. We don't want to mix that API code into our task. We want something else to deal with that for us. So what we're going to do is we're going to create a task repository. And that task repository is what's going to deal with all of the API calls for us. And so then down here, what we want to be able to do is do a task repository.save and pass in this task object and have that deal with all of that database stuff for us. Now, the first thing we're going to do when we do that is we're going to create a new file called task repo. And this is where we're going to build that module. If you remember in our other code, in our Node code, we had a repo, get and save, and that's all it had on it. We're actually going to copy this function. And then we're going to use that over here. So we're going to start with our IFI, and we're going to get our Angular application. That's the first thing we always want to do. So var app equals angular.module, and we want task manager. That's what we created it over here as Angular.module task manager. So that's what we're going to pull in. All right. So we're going to create a task repo, and that's going to be a function. And we can actually paste this same code, get rid of the double function there, and ask for $HTTP, and it works the same way. So I now have a task repository with a get function and a save function, and then we're using that revealing module pattern down here where we have a get and a save. Now the only thing we still have to do, let's beautify that a little bit so we know what's going on, is add that to our Angular application. So app.service, and we are looking for task repository, and we're going to pass in this task repo function that we've created. So basically all this is, it's the same thing we did on the Node side. This is a object with a get and a save, and we're returning get and save. It's going to handle all of that code for us. And then over on the task side, we're just going to call that. When we click save, we're just going to call that save to this. Now, one other thing we want to do, notice we're never actually calling save. So task.prototype.complete, when we complete a task, we're going to set it to completed. We're also going to save it. So let's do this. This dot save. All right, so what we should see in our console when we run this is we should see completing task, task 1. We should see in our repository saving task 1 to the database when we do all that. So I'm going to click. One very important thing we did not do is add our task repo. There we go. To our scripts. Okay, now I'm going to refresh. And when I click task 1, completing task 1, saving task 1 to the database. So now all of our HTTP code, all of our API calls and everything like that can be pushed out to this repository built using the module pattern. So we just have a module that handles all that stuff for us. Now, on the get side, we could do the same thing. We're not going to do it right now, but I would challenge you to go ahead and try it. If you go to your script.js, here I'm pulling in some tasks. This would be the same thing. I would pull these in from my task repo and then create new tasks out of it. So the next pattern we're going to talk about is the factory pattern. And this is a pattern that is used to create objects for us. And sometimes the creation of an object can be complicated either because of configuration or other factors. And a factory pattern is used to simplify that and hide a lot of that from our front end. So basically, a factory pattern comes down to a couple of things. One, simplifies object creation, like we just talked about. If I have a repository, I've got to open a connection to the database, and I've got to set up caching and all of those different things that I don't want to do in my controller or in my routes. And so I'm going to use a factory to deal with all of that code for me. It's also good at creating different objects based on need. So if I need different types of objects based upon where I'm at, that's something that the factory pattern is good at. And we're actually going to look at that in our example because we're going to do repository creation. Now we've already created a task repository and we just call out to the task repository to do everything we need. Now on my controller though, I might have a task repository, I might have a user repository, I might have a project repository if we're going to split up our tasks by project. And I don't want to have to pull all of those different repositories into my route or my controller. So what we can do is we can create a repository factory that's going to pull in the necessary repository that I need at the time, and our controller doesn't have to worry about all of that. So let's take a look at how this works on the Node side when we're dealing with factories and repositories. All right, so what we've got here is an application that's going to pull in 3 different repositories. We've got a task repository, we've got a user repository, we've got a project repository. And what this application is doing is then using those 3 repositories to new up a new task and add a user to the task and add a project to the task. and then we're going to save that out to the database. So what this ends up looking like is kind of junky, because up here at the top, you've got 3 different repositories that you're pulling in, and it can kind of add a lot of stuff to this main.js. And that's not what we want to have happen. But what I'll show you real quick is what this looks like when we run it, just so you can see. Notice we're newing up a task repository, getting task 1, user 1, project 1. Then there's our console.log task. There's our task, and then we're saving it to the database. Okay, what we're going to do is we're going to add a factory, and that factory is going to replace lines 2 through 4 and get rid of those, so that we're not having to change main.js or add repositories in here every time we want to pull from a different data source or something like that. We want something else to deal with those things for us. And so we're going to use the factory pattern to create these repositories for us as necessary. So let's look at a repo factory. Now, this is just a simple factory with a function called getRepo. And that function takes a string that's just the repository type, and then checks what type of repository I'm looking for, task, user, project, and will then return a require to that task repository or user repository or project repository. So the very simplistic thing that this looks like is, hey, give me a repository and I'm going to give you the type. So in main2.js, we've converted this, and now I can call repofactory.getRepo and the task, and that's going to return back a instance of task repository. And then it will give me a user or a project based upon what I'm sending back. Notice up on line 2, I only have my repo factory. Over in main.js, the way we were doing this before, I had 3 repos up here. Now I just have the factory. Now this isn't quite super awesome, because I've added something to my task repository that down here on line 16, console.log, newing up a task repo. And when I run main2.js, I'm newing up task repos all over the place. So this isn't the end product. This is just where we're starting. So what we're going to do instead is we're going to cache our repository. So I've created a new one, repo factory with cache. And now if you look, repo equals task. Then if I check to see if this .task repo exists already, and if it does, I just hand it back. Otherwise, I new up a new task repository and return that. What that does for us is, instead of creating a new task repository every time, I can just go and cache that in my factory. One thing to keep in mind is I might have config code right here. That's part of the benefit of the factory pattern, is I can drop all my config code in the factory before I return it, and then I don't have to deal with that over on my main.js code. All right, so let's look at our main2.js, where we're using the repo factory, and now let's switch it over to use the one with cache. Now what you'll see when we run this, if you look here, we've got 3 newing up task repos. This first one and the third one are from creating these 2 new tasks. The second one actually comes from our task, where it news up its own task repository. And I'm going to leave that there for right now. So what you're actually going to see is we'll just drop one of these. We'll drop the second one, and this will be coming out of the cache. And we can actually say, come right down here and put a console.log in, retrieving from cache. Let's run that. All right, see now that newing up task repo here became retrieving from cache. So now we're caching our repositories kind of just as they're needed. We're not loading them all up right away. We're just caching them as they're needed and then running them that way. All right, so that's a simple factory. Just, hey, I'm going to go and get something and pull it back. If you look at our code, though, this repo factory.getRepo task.get, that's kind of kludgy and it feels kind of icky. So there's one other way we're going to look at to use our factory to clean this look up a little bit. So the way we're about to implement the factory pattern actually is used in gulp load plugins. So if you use Gulp at all, Gulp Load Plugins is a fantastic tool that basically runs this factory pattern over all of the Gulp plugins that you might use for your code. And let's take a quick look at what this looks like. So basically you do var gulp equals require gulp, and then gulp load plugins equals gulp load plugins. And what gulp load plugins is going to do is it does all the requires for every gulp dash thing. It looks in your package.json file and all the gulp dash stuff, it just loads that on its own. So now I have plugins.js hint or plugins.concat. And that just simplifies everything up in the top area of your gulp file. We're going to take this same basic idea and do it for our repositories. So what I want to do, if you look at main3.js now, I want to do repofactory.task or repofactory.user or repofactory.project. Main 2, we had to do repofactory.getRepo task and .get, and I don't, like I said before, that looks kind of kludgy. So what we're going to do now is we're going to implement a factory that lets me do this, repofactory.task. And you can actually change repofactory to just repos and have it look nice and clean. So let's look at how we implement that. So the way we start here is I'm going to create a copy of this called repos. So repos just refers back to the object scope for repo factory, because down at the bottom when we do on module.exports, I'm newing up that repo factory. So this repos refers to the object scope for my repo factory, and I'm going to use that here in my for each callback. Now, I have a list of repositories, and this list could come from anywhere. I could look at a specific directory. I could just go out, hey, let's go out to my /repo directory and load all of the files that are in that repository directory and drop everything before repository. So now I've got task repository, the name is task, the source is /task repository. Then I just do a simple repo list.forEach and repos.name. Remember when we were talking about objects, I'm using bracket notation now because I'm using a variable to add. So repos bracket notation repo.name. So .task, .user, .project equals require, and I just require my source. So repos bracket task equals require /task repository. Repos user equals require, and I just run all those requires right there. What that does for me is now look back at main3.js, I have this very simple, clean repofactory.task, repofactory.user. And the factory is taking care of creating all my repositories for me. I don't have to worry about any of that stuff. And pulling all that back, and now in my main, it's just this simple little, hey, I've got a repo factory, and here I'm pulling tasks, I'm pulling users, I'm pulling projects, and everything just works. And if we run main3.js, there we go. Everything just works. Now, notice we're not pulling anything from cache, and that is because everything was cached inside my repo factory. So when I created a new repo factory, it just cached it in my repo factory automatically, and then it dealt with all of that caching for me. The next pattern we're going to talk about is the singleton pattern. And the singleton pattern is used to restrict an object to just a single instance of that object across your entire application. Now, the way a singleton works is that it remembers the last time you used it. So the singleton is an entity, remembers the last time you used it, and then hands you back that same instance that you used before. So typically a singleton looks something like this. In this case, sticking with our repository idea that we had from our factories, we've got, in this case, a task repository that we're going to create as a singleton. Now, the first thing you're going to do is create a task repository object. And in this case, we have a var task repo, and that task repository is this object that we're going to create. And we have a create repo function that creates a new instance of that repo when we're ready for it, and then it returns that back. So when I want a new instance of my repository, I call this function getInstance on my singleton. On my task repository singleton, we have a getInstance function that checks to see if not a task repository, if that task repository hasn't been created yet, I'm going to create one. Otherwise, I'm just going to return the one that I've already created. So basically what happens when I create a new repo 1 and repo 2, I'm calling getInstance. And when I call getInstance for task repository, it just calls out. And the first one goes and creates a new instance, and then the second one already has that instance, so it just returns it. And actually, if you check with an if, they'll be the same task repository. Now, one thing to remember when we're dealing with this, Node.js uses the common JS module pattern. And Angular even does something a little different that kind of makes the creation of singletons in our applications a little less painful. All of this stuff we just looked at about get instance and all those things, we don't have to do in Node because of the way it uses common JS, or we don't have to do in Angular because of the way it creates its services. So let's look at how we create singletons and how singletons work in Node and Angular so that you understand kind of how that common JS pattern works, so you don't get stuck using a singleton if you don't want to be, or you are using a singleton if that's the idea that you want to do. So let's look at Node and this common JS module pattern and how singletons work in that environment. Now I've created a repository, just a simple repository that has one method called save. And I've added just an integer number to this repository called call that's going to keep track of how many times that save method is called. And then when you call save, I'm just going to write out to the console saving whatever we've written, and called has been called however many times. Now we have a main.js, and this main.js is creating an instance of task handler. So task handler, if we look over here, creates an instance of the repository, and then task handler.save is just going to write out my repo.save. It's going to create a new task in the repo, hi from task handler. So every time I call save, it's just going to call my repo.save again. And then main's going to do the same thing. So right now, if I run this, my repo.save, I'm going to have 3 from main, and then I should have 4 from task handler. So when I run this, notice I get 2 newing up task repos. So I've created 2 instances of this task repo. And then I saved from main, called it 1, 2, 3, and then saved from task handler, hi from task handler, called 4 times. So we obviously don't have a singleton of my repository because I've got 2 different instances of this repository. One instance is sitting in main, this instance right here, and then task handler has an instance of my repo as well, but it has its own instance. Now, what CommonJS does, if we look at the Node documentation, is caches everything that is in a require. So if we look at caching, right here, the first paragraph, modules are cached after the first time they're loaded. Every call to a require of something, I'm going to get the exact same object returned. So this third paragraph is what we're doing right now. If you want to have the module executed code multiple times, export a function and call that function. So what I'm doing right now in my repo, module.exports in my repo, module.exports equals repo. I'm just exporting this function, and then I'm requiring main to execute that function in order to get a repository they can use. A lot of times what you'll see is a require, and then you just stick that at the end of it to execute it. So when I do that, what's being cached in the module export is the whole function. Now what I can do, and what a lot of people do, is I can execute that function in my module.exports. And when I execute that in my module.exports, I have effectively created a singleton of my repository. Because what Node.js is going to do is it's going to store that instance of this return object, this object right here that's returned, it's going to store this. And the closure around this function means called and save and all these things are going to stay the same. So now here, I don't have to execute it anymore. So I can get rid of a couple things. Let me change this around. Change that to my repo, get rid of that line, and over on task handler, I'm going to do the same thing. I'm going to get rid of my repo and change that there. Now, the only thing I've changed is I'm not executing the function because I'm executing it over on my repo when I do my module.exports. Now, what that means is now when I run this, I have effectively created a singleton of my repository. So I'm only going to see one newing up task repo, and I'm going to see 1, 2, 3, 4, 5, 6, 7, 8. So when I run it now, I only have one newing up task repo, 1, 2, 3, 4, 5, 6, 7 on my execution. So that's a very clean, very simple way to create singletons on my node side. And you see this happen a lot, especially if you're doing Mongoose or MongoDB or Express. Module.exports usually will export either a repo like that, or I could actually new it up and do new repo, and it's going to work the same way. And you'll see this a lot as you look at packages. A lot of packages will just execute a new instance of whatever it is they're doing, and they have effectively, because of the way Node handles their modules, they have effectively created a singleton of that object. Now let's look at singletons in Angular. And this is actually going to be pretty easy and straightforward because in Angular, all services are singletons. That's just the way it works. Actually, if you come over to that plunk that we've been using, I've changed some things a little bit, but if you look at our task repository, get rid of this for right now, at the bottom where I do an app.service task repo, what app.service does is it actually calls new task repo. It goes ahead and news it up right there and then serves that back and forth. And because it does that, because it news it up automatically, just the same way we were dealing with the node side, it's going to hand that same service back and forth to everything. And let me demonstrate to you what that looks like, just so that you trust me, that you know that this is what it does. So I have the task repo, but I've added this called variable in the same way we had it over on the node side when we were looking at the node singletons. And I have a get method, and I increment called, and I added called on the end. And I have a save method doing the same thing. Now I'm using this task repository in two places. The first place is on script.js, just in my main controller. When I'm building out my task list, I'm pulling from task repository 1 and 2. And so what you will see is when I run this, if I pull up my console, you see right here down at the bottom, getting task 1 called 1 time, getting task 2 called 2 times. Now I'm also using this repository over on our task. When I do a save, task repository.save this, what save is doing is just writing out to the database, or in this case just the console, saving task name to the database, and I've added that called. So task.js is using task repository just the same way that my controller is using task repository. Now when task.js executes save, what you see happen is saving task 2 to the database, I've now been called 3 times. Saving task 1 to the database, I've now been called 4 times. And every time I click this, I'm just incrementing. So singletons, in the context of what we're talking about, are fairly predominant. Almost everything's a singleton. If I new it up on the node side before I hand it back to my module.exports, then that becomes a singleton just by virtue of the way CommonJS works and the way modules work in Node. If I create a service in Angular, then that service becomes a singleton. That's just the way Angular is going to work when it's dealing with services. So that's the different way we create objects. Let's sum that up real quick. So to sum up, we've been talking about creational design patterns. These are patterns that we use to create new instances of objects whenever we want something done. And we talked about a few, the first one being the constructor pattern. And the constructor pattern is what we use to create a new instance of an object. And typically with the constructor pattern, that's when we're going to have a few of something. So in our examples, we use tasks. I wanted to create multiple tasks. And we talked about prototypes and how the prototype worked on JavaScript. Talked about the module pattern. The module pattern is when I want to bundle a group of like things together and create just a bundle of methods. We used repositories as just a bundle of methods that we could use to interact with the database or an API or something like that. Talked about factories. We used repositories for our factories, and we created a factory repository that would create these repositories for us so that we don't have to have all those repositories listed out in our requires on our main JavaScript. And the last is singletons. And we talked about how singletons work in the modern era for JavaScript and Angular and Node, just so that we know that a lot of times we're dealing with singletons when we don't really even realize we're doing it. And so how to avoid that situation if we want to on the Node side and understand the implications of dealing with singletons. Now that's creational design patterns. Now let's take a look at some other types of design patterns in the next module.